When dealing with LED reverse channel letters, the color coding of the low voltage conductors can sometimes be misleading. It's not always safe to assume that black is positive and white is negative, or that black is positive and red is negative. These are low voltage direct current, or DC circuits, and proper polarity is essential for the LED to function correctly. If you reverse the polarity, the LED simply won't light up. It is important to understand that there isn't a universally mandated standard for low voltage DC wiring color codes in the context of LED signage. While in alternating current, or AC, systems in North America, black typically indicates a hot or live wire, white indicates neutral, and green indicates ground. These conventions don't necessarily translate to low voltage DC circuits. Sign manufacturers may choose different color schemes for their own internal wiring. Because of this lack of standardization, relying solely on color codes to determine polarity can lead to errors and improper installations. Always verify polarity by consulting the manufacturer's documentation or using a multimeter to test the voltage. The best approach when installing LED reverse channel letters is to first identify the manufacturer's documentation. This documentation will typically include wiring diagrams that clearly indicate the positive and negative terminals for the low voltage DC power supply and the corresponding connections to the LED modules within the letters. Look for markings or symbols that denote polarity, such as plus signs and minus signs, or positive and negative symbols. If the documentation is unavailable, the next step is to use a multimeter to determine the polarity of the conductors. Set the multimeter to DC voltage mode. Connect the black lead of the multimeter to a known ground point or the negative terminal of the power supply, if accessible. Then touch the red lead of the multimeter to each of the conductors in question. If the multimeter displays a positive voltage reading, a conductor connected to the red lead is the positive conductor. If the multimeter displays a negative voltage reading, a conductor connected to the red lead is the negative conductor. If there are any markings in the power supply indicating the polarity of the output terminals, always follow those markings. These markings usually consist of plus signs and minus signs or positive and negative symbols. Also, carefully inspect the LED modules themselves. Often, the modules will have polarity markings near the terminals where the wires connect. These markings will help you determine which wire should be connected to the positive terminal and which wire should be connected to the negative terminal. Be especially careful when dealing with different sign manufacturers or even different models from the same manufacturer. The wiring color codes can vary. Never assume that the color code used in one installation will be the same in another. Always verify the polarity using the methods described above before making any connections. If you encounter a situation where the wiring colors are ambiguous and you are unable to determine the polarity using the manufacturer's documentation or a multimeter, it's best to contact the manufacturer directly for clarification. They will be able to provide you with the correct wiring information for their specific product. Incorrect wiring can cause several problems. Firstly, the LED will not light up if the polarity is reversed. Secondly, incorrect wiring can damage the LED or the power supply. LED are designed to operate with current flowing in one direction only. Reversing the polarity can cause excessive current to flow through the LED, which can lead to overheating and premature failure. Thirdly, in some cases, incorrect wiring can create a short circuit, which can damage the power supply and potentially create a fire hazard. To prevent these problems, always double-check your wiring before applying power to the circuit. Use a multimeter to verify the polarity of the connections and ensure that all connections are secure. It is important to use appropriately sized conductors for the low-voltage DC wiring. The size of the conductors will depend on the current draw of the LED modules and the length of the wiring run. Use a wire size chart to determine the correct conductor size for your application. Using conductors that are too small can cause excessive voltage drop, which can reduce the brightness of the LED and potentially damage the power supply. Ensure that all wiring connections are properly insulated to prevent short circuits and electrical hazards. Use wire connectors or electrical tape to insulate all exposed wires. Consider using heat shrink tubing to provide additional protection for the connections. Make sure the power supply is properly rated for the total current draw of the LED modules. Using an undersized power supply can cause it to overheat and fail. It can also reduce the brightness of the LED. If the LED reverse channel letters are installed outdoors, ensure that all wiring and connections are protected from the elements. Use weatherproof enclosures and connectors to prevent water damage and corrosion. Regular maintenance is essential to ensure the long-term performance and reliability of the LED reverse channel letters. Inspect the wiring and connections periodically for signs of damage or corrosion. Replace any damaged or corroded components immediately. Clean the LED modules regularly to remove dirt and debris. Dirt and debris can reduce the brightness of the LED and can also cause them to overheat. When working with electrical wiring, always follow proper safety precautions. Wear appropriate personal protective equipment, such as gloves and eye protection. Disconnect the power supply before working on any wiring connections. Never work on electrical wiring in wet conditions. If you are not comfortable working with electrical wiring, consult a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. Always adhere to local electrical codes and regulations when installing and maintaining LED reverse channel letters. These codes and regulations are designed to ensure the safety of electrical installations. When choosing an LED power supply, look for one that is specifically designed for use with LED lighting. These power supplies typically have features such as overvoltage protection, overcurrent protection, and short-circuit protection. These features can help to protect the LED and the power supply from damage. Consider using a constant voltage LED power supply. Constant voltage power supplies are designed to provide a stable voltage to the LED, regardless of the current draw. This can help to ensure consistent brightness and color uniformity across the whole of the LED. Some LED power supplies have dimming capabilities. If you want to be able to dim the LED reverse channel letters, choose a power supply that is compatible with the dimming control system. Several different types of dimming control systems are available, such as phase cut dimming, pulse width modulation, or PWM dimming, and digital addressable lighting interface, or DALI dimming. Make sure that the dimming control system you choose is compatible with the power supply and the LED modules. When wiring the LED modules, it is important to maintain consistent polarity throughout the entire circuit. Use the same color wire for the positive connections and the same color wire for the negative connections. This will help to prevent confusion and errors during installation and maintenance. If you are using multiple LED modules, it is generally recommended to wire them in parallel. Wiring the modules in parallel ensures that each module receives the same voltage. If the modules are wired in series, the voltage will be divided among the modules, which can reduce the brightness of the LED. Before connecting the LED modules to the power supply, test each module individually to ensure that it is functioning correctly. Use a multimeter to measure the voltage and current of each module. If a module is not functioning correctly, replace it before proceeding with the installation. When making wiring connections, use high-quality wire connectors that are designed for use with low-voltage DC circuits. Avoid using wire nuts or other types of connectors that are not specifically designed for low-voltage applications. These connectors can loosen over time, which can cause poor connections and electrical problems. Consider using a terminal block to make the wiring connections. Terminal blocks provide a secure and reliable way to connect multiple wires together. They also make it easy to disconnect the wires for maintenance or troubleshooting. When routing the wiring, avoid sharp bends or kinks in the wires. Sharp bends or kinks can damage the wires and can also reduce the current carrying capacity of the wires. Use cable ties or other types of fasteners to secure the wiring and prevent it from rubbing against sharp edges. If the LED reverse channel letters are installed in a location where they are exposed to direct sunlight, consider using UV-resistant wiring and connected. UV radiation can damage the insulation on the wires and can also cause the connectors to become brittle and crack. When installing the LED reverse channel letters, make sure that they are properly grounded. Grounding helps to protect the LED and the power supply from electrical surges and other types of electrical disturbances. Use a grounding wire to connect the metal frame with the letters to a suitable grounding point. Regularly inspect the LED reverse channel letters for signs of damage or wear. Check for loose connections, cracked lenses, and other types of damage. Replace any damaged components immediately. Keep the LED reverse channel letters clean to ensure optimal performance. Use a soft cloth and a mild detergent to clean the lenses and the metal frame. Avoid using harsh chemicals or abrasive cleaners, as these can damage the finish. By following these guidelines, you can ensure that the LED reverse channel letters are installed correctly and that they provide years of reliable service. Remember to always prioritize safety when working with electrical wiring. If you are not comfortable working with electricity, consult a qualified electrician. The National Electrical Code, or NEC, doesn't specifically address low voltage DC wiring for LED signage in a dedicated section. However, several articles and sections of the NEC apply to these installations. Firstly, Article 311 covers wiring methods, including general requirements for wiring in raceways, cable trays, and other enclosures. This article emphasizes the importance of proper support and protection for wiring. Secondly, Article 410 addresses luminaires, lamp holders, and lamps, including LED lighting systems. This article covers requirements for the installation, wiring, and protection of luminaires. Thirdly, Article 600 covers electric signs and outline lighting. This article provides specific requirements for the wiring, grounding, and protection of electric signs, including LED signs. Several other NEC articles are also relevant to LED signage installations, including Article 250, which covers grounding and bonding, Article 310, which covers conductors for general wiring, and Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. The specific requirements that apply to a particular LED signage installation will depend on the voltage, current, and location of the installation. It is important to consult the NEC and any applicable local codes before beginning any electrical work. Regarding reverse polarity issues, Section 410.48 of the NEC addresses the identification of terminals. While primarily focused on AC systems, the principle of correctly identifying terminals is applicable to DC systems as well. In DC circuits, proper polarity must be maintained to ensure correct operation of the equipment. This section reinforces the importance of clearly marking terminals for proper identification.